Yeah, I wanted to talk a little bit about the encoder that I want to put on this unit. Now, I found two places on YouTube. This one, Curious Scientist, he's got a AS5600 magnetic position encoder. That looks really promising. Then there's this other one, Atomic 14, building a custom rotary encoder with the AS5048. I looked at both of those, and the second one, you could build it with two types of encoders. Well, I think it's one encoder, but two types of driver boards. I'm not really quite sure. It's a little more technical than I understand. I'm looking for something simple, and this one from Curious Scientist, what he's doing with his is he's reading the angle from the back of a encoder motor. Actually, what he did was he put a little turn knob on the front of the motor, and he's rotating the motor, and it's reading off of a little display. And that looks like the simpler one, even though the code that he posts on that is quite long and quite involved. And he has a lot of flickering on his screen, and the letters are awful small. And the one from Atomic 14, he has a nice size screen, and he's got nice size letters. The lettering on his is exactly what I'm looking for, and there's no flickering, and it goes to 360 degrees, well, 359, and then it goes back to 0, and that's really what I want. As to where this other one, it just continually climbs as much as you turn it. It goes 359, 360, 400, 500, 600. It just goes and goes and goes. But I'm not understanding the code on this Atomic 14. I'm going to look at it some more, but I figure that they're both basically identical. They have a magnetic encoder on the back of a shaft, and then it goes into it's a Uno, but it's not the full size one. It's a little small one, Nano or something. I'm not really quite sure because I know what the picture looks like, and it's small. But anyway, I'm thinking that I'm going to go ahead and get started on this. At least if I build the, I don't know what you call it, I got to build the mounting brackets and everything for it. And then when I get to the actual code and which one I'm going to use, I'll have to decide later. I might have to try one and then try the other one, and if one works, I'll have to go with that, even though it's not what I want. But anyway, I just wanted to kind of go over the ideas I had about this. Let me put you up here. So as far as the, if you can see that, so it's got to be mounted on the unit. Now I got the servo motor over here, and it goes from the belt over here. And the thing is that I can't mount it on the servo motor because I have a 3-to-1 reduction. So the code would be off. So I'd have to mount it on here somehow. And it would have to be on the axis of the shaft. So we got the piece that goes back here, and there's nothing precision about it. It slops around, and you know, it's basically just for tightening the collet. So it'd be really, really hard to put something back here that would be concentric. And I got this piece. That goes in there, and you really, you know, that's a lot of slop in there, and be hard to. I mean, I could mount something on here because I got the holes. I could put more holes in there, but it wouldn't be concentric. I'd have to put a bushing in there, and then every time you want to, you know, change a part, you got to loosen that, tighten it back up, and whatever you have back here, a magnet, has got to be so close to the little chip in the back that, you know, when you load this and unload this, you got to move that, move this, and so that's just not practical. And I don't think I can mount it on here. I got this little hole up here I can mount it on, but that's on the outside of this shaft, so I have to mount it here on the front. So if I take this cover off, I can't actually mount it here, but I have to mount it. I can mount a gear here, and then have the gear come off to the side, have another gear. Both of the gears would have to be the same exact size because you don't want any gear reduction in it. You want a 1-to-1. So I can mount a gear here, put a plate here, mount another gear, and then have it go through here. You could have a part that holds the magnetic piece, the little chip part. It's a little plate with a little chip in the middle, and as the magnet rotates, it reads the position of the magnet. It's a special magnet. You know, one half of it is south, the other half is north. But they're common. You can buy them. But I have to make something. It's basically a jack shaft, 1-to-1, and then have something back here. And then the magnet itself, where the other pulley is, the shaft that goes through there, I can mount the magnet on it, and then have the little board with the chip on it. I could position it to read the magnet. So I got this, the mounting holes that I use for this, I could use those mounting holes to attach a plate over here or over here. You know, if you put it on this side, these holes are symmetrical around the vertical axis, so I could mount it this way, or I could flip it over and mount it this way. It doesn't matter. Probably mount it to the outside. I don't know how much room it's going to take, because you don't want, on the inside I got the stepper motor over here, and I got that little counter wheel here that I use to check the angle. Of course that can be removed, but we'll see what happens, but I think it's feasible, and I think we can make it work. And that would be nice to have a little LED display showing the degrees you are instead of trying to read it off this wheel. I mean, it'll work for now, but a little LED screen, of course I'd have to have some wires come off of here, and I'd have to have a place to put the little board, the little chip board, and a place to put the screen. And I mean, there's a little bit to it. It's not just a bolt-on operation. It's got to make this, make that, make it work, make sure the code works, make sure the angular rotation works. But I think we can get there. All right, this is going to be the start of another long one. Okay, talk to you later.